Now what about multiplying square roots, or multiplying these radicals together? How do we do that? Well, we multiply radicals by multiplying the inside and multiplying the outside separately. So what's under the square root and what's not under the square root separately, and then we'll try to simplify. So for example, in this first one, we've got the square root of 3 and the square root of 6. Since 3 and 6 are both under the radical, I'm going to multiply those together to get 18, the square root of 18, and then try and simplify that. Do any of my perfect squares, right from above, divide 18? And in fact, they do. We know that 9 divides 18, so we can break 18 down to the square root of 9. And what's left over? I guess 2. Can we pull anything else out of that 2? No, there are no other perfect square factors. But the square root of 9 is 3, so that simplifies to 3 square root 2. In the second problem here, we've got negative 5 root 6 and 5 square root 2. So with this, we will rearrange this. You could think of doing this. Negative 5 times 5, multiplying those numbers outside the radical, and the numbers inside the radical, the 6 and the 2 separately. So we end up with a negative 25 outside the square root, and inside the square root we end up with a 12. And again, we ask ourselves, can we simplify this at all now that we're done with multiplying? And we think, what number is going to 12? What about 4? We can divide out 4. So the square root of 12, we can save the factor of 4. That's 4 times 3. Bring down the negative 25. And is there anything we can do with that square root of 3? No, there's not. No other perfect square factors. But we can save the 4. The square root of 4 is 2. And it joins this negative 25 outside. So the simplified version of this is negative 50 square root 3. Let's take a look at this last one right here. If you're feeling comfortable with the first two, pause the video now and try this third one by yourself. Then unpause the video to see how you did. Please pause the video now. Alright, let's take a look. Outside, 5 and, well, what number is out here? Remember, we can always put a coefficient of 1 in front of any radical. So we have 5 times 1 on the outside of our radical, and on the inside of that radical, that square root, we have 10 times 8. Now, 5 times 1 is 5, and 10 times 8 is 80. And can we simplify this at all now that we're done multiplying? Well, I know that 4 divides 80, so the square root of 4, and it's 4 times 20, I believe. Bring down that 5. So we can save that square root of 4. Is there anything else we can save in that square root of 20? Any other things we can factor out? Well, what about another 4? We can bring down the 5, the square root of 4. 20 is 4 times 5. And there's no other perfect square factors we can take out of 5, so this is where we end it. 5 times the square root of 4 is 2. The square root of 4 is 2, and there's nothing we can do with that square root of 5. And so these are all being multiplied together, and so 4 times 2 is 20, and the square root of 5. So the simplified version of this is 20 square root 5. Now occasionally we're going to have to square a square root, as in these kinds of problems right here. Now I wrote that square root cancels out the square. But what do I mean by that? Well, let's take a look. The square root of 3 squared. Squaring something is like multiplying it by itself. So the square root of 3 squared is just the square root of 3 times the square root of 3. And remember, we multiply the values on the inside of that square root symbol. So that's going to be 3 times 3, which is the square root of 9. Wait a second. The square root of 9 is just 3. So if you look what's happened here, the square root of 3 squared is just 3. We could have done this a little faster if we realized that, hey, squaring and taking a square root are inverse operations, and they tend to undo each other or cancel each other out. And so when you see these things, you can just cross them out together and realize that the square root of 3 squared is just 3. It gets a little tricky here with the next one. We have 2 square root of 3 squared. Now, that would be 2 square root of 3 times itself, 2 square root of 3. And we learned before with multiplying, we multiply the outsides, 2 times 2 to get 4, and the numbers under the radical, 3 times 3 to get 9. Now, the square root of 9, we don't have to do any simplifying there. I mean, we know that the square root of 9 is just 3. So this is 4 times 3, which is just 12. But, just like in the last one, we could have done this a little more simply. When we're squaring this whole term right here, this is like 2 squared and the square root of 3 squared. Like we said before, the square and the square root of 3 cancel each other out. So this is kind of like writing 2 squared times 3, because again, the square and the square root on the 3 cancel each other out. 2 squared is 4 times that 3 that we've freed from under that radical, and 4 times 3 is 12. So either way, we have the same answer. Whether you'd like to multiply the number by itself or use inverse operations, we get 12 either way. If you're feeling pretty good about the last couple of problems, try this third one by yourself. Pause the video now. Alright, let's try it. We have 4 square root of 5 squared. Now if you like doing it this way, writing it out by multiplying it by itself, you can do that. 4 square root of 5 times 4 square root of 5. I'm going to multiply the outsides. 4 times 4 is 16. Square root of 5 times square root of 5 is 25. The square root of 25 is a perfect square, that's 5. And 16 times 5 is 80. On the other hand, if you like using inverse operations, that's fine too. You should have to kind of distribute the square to both the 4 and the square root of 5. And remember, the square root and the square cancel each other out. So we are left with 4 squared times that 5 that's been taken out of that square root because we squared it. Remember, 4 squared is 16 times 5, and 16 times 5, as we know before, is 80. Either way is perfectly acceptable.